Hi guys, this is Snow. In this video, I will show you how to create an A-star pathfinding demo program in Java. In case you don't know, A-star pathfinding is a popular path search algorithm which was developed and introduced by Stanford Research Institute in 1968. The purpose of this algorithm is finding a best path from point A to B, and because of its nature, it is widely used in video game development. So if you are developing a game, maybe you have wondered how to guide a certain character to a specific point. For example, when a monster finds you, maybe you want them start chasing you, or when you talk to an NPC, maybe you want them follow you or walk to a specific location or something like that. But how to do that? If this NPC is always standing at the same spot and the goal that you want him to go is always the same spot, maybe you can manually script his movement, but this is a tiresome process, and also if this NPC is moving around, his starting position changes depending on where you talk to him. Not only that, maybe there are some solid tiles between the character and its goal. Maybe some monsters or other NPCs are moving around, and maybe this NPC bumps into them. Then it disrupts his movement. So the situation on the screen is often changing. So many developers implement an algorithm so the characters can automatically calculate the best path, always adopting the situation on the screen, and don't get stuck like charging into a solid tile forever. And the A-star algorithm works really good for this purpose, and it's considered as one of the most popular pathfinding algorithms. So this time we will create a simple demo program to understand its fundamental mechanics. I will show you every single step to create this demo, so hopefully you get enough knowledge to apply it to your own game. Anyway, enough about introduction, so let's start. And first we create a window. Then create another class. I'm gonna name this demo panel, and this class extends jpanel, not extends. And first we choose screen settings. So basically we display multiple kind of blocks. We call it a node that represents tiles in the game. So first we choose max column and max row numbers. So you can choose any number, but I'm gonna choose 15. And then final int, we're gonna choose this node size. This is also, you can choose whatever size you want. And based on these numbers, we set the screen width and the screen height. Okay, then create a constructor. And here we set the size of this demo panel. And also background color. And then set the layout. So we're gonna place a bunch of nodes on the screen. So max row, max call. Okay, then back to the main class. We add this demo panel to the window. And pack window.set location relative to no, and set visible. Let's check. So the window shows up. Now we're gonna place nodes on this window. So we create another class and name this node. And this class extends JButton and implements action listener. Okay. So basically this node is a button. So it responds to your mouse click. And we're gonna declare some class and variables here. First node. Name this parent. And int column low g cost h cost int f cost and also some boolean start goal solid open boolean and checked. Okay, that's all. So I will explain these meanings later, so just a moment please. And then create a constructor public node and we receive call and allow this call this allow equal allow. Okay, and let's set the background and the foreground color for this node. So I'm going to choose white, black. So this is basically the text color. And also let's add action listener. This. Yeah. And we implement the result of clicking this button. So when you click this button, then we change its background color to something different. So I'm going to choose orange. Okay, back to the demo panel. And now we declare the node as two-dimensional array. And we're going to set max call and max allow. Okay, then we're gonna place these nodes on this panel. So int call 0 allow 0. So we're gonna create while loop call less than max call and allow less than max allow. Okay, so node call allow equal new node, and we're gonna pass this call and allow to the constructor, and then we're gonna add this instantiated node to this array. And then after that call plus and if call equal max call we reset the call and allow plus. Okay, let's check. Yep, we have placed 15 nodes horizontally and 10 nodes vertically, and the node becomes orange if you click it. Then let's choose the starting point and the goal. So we declare some more nodes and name them start node, goal node, current node. Then in this node class we create some method public void set as start. So set background color dot. So I'm gonna choose blue color for this start node. Set foreground and the text, and also let's display text on this button, so start. And also we're gonna change this this start boolean to true. We're gonna copy this and paste, and this time set as goal. I'm gonna choose yellow color, and text is black. The goal is true. Then back to the demo panel, we create method like these: private void set start node receive call and allow node call allow that set as start. We're gonna put this node to this start node, so we call node call allow, and also current node equal start node. So at the beginning of this program, the current node is equal to this start node. Then copy and paste and goal node and set as goal node, and we don't need to set it as current node, so delete this. And we call these methods and pass this call and allow from somewhere. Anywhere is fine, but for example inside of this constructor. So set start node, so I'm gonna pass call 3 and allow 6, and set call node. I pass 11 and 3. Okay, let's check. Yeah, so the start node and the goal node are displayed now. If the field is totally open like this and there is no obstacles between them, finding the best path is easy. It's like probably this, or like this, or like this. Either way, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps, and you don't really need an algorithm to find this out. But what if there are some solid tiles like this? Then suddenly it becomes difficult. You know, maybe like this, or maybe like this. It's not easy to find out on the spot. So this is where the A-star algorithm comes in. So let's place some solid nodes so we can create a sample situation. Inside of this node class, we're gonna add method public void set as solid, and set background. So I'm gonna choose black background for this solid node, solid tile or solid node. Foreground is also, we're not gonna display any text, so I'm gonna just choose black. And solid equal true. Yeah, which one? This one. Demo panel, private void set solid node call int allow node call allow set as solid. Then we call this method and pass the call and allow of the node that we want to set as solid. So set solid node 10 to Yeah, something like this. So let's check. Yeah, okay. So now we have created a sample situation. So let's talk about the mechanics of A-star pathfinding. So to evaluate the best or shortest path, A-star algorithm uses three numbers, and they are called G cost, H cost, and F cost. And G cost means the distance between the starting position and current position, so where the character is right now. And H cost means the distance between the current position, whatever you are, and the goal. And F cost is the sum of this G cost and the H cost. So in this demo, every node has these three costs, and the algorithm evaluates these costs and find out which node is the most promising node to reach the goal. And among these three costs, F cost is the most important one, since it indicates the total cost. So for example, so this tile or node, whatever you call it, so this node's G cost is 4 because 1, 2, 3, 4. So 4 nodes away from the start node. And the H cost is 1, 2, 3, 4, 5, 6, 7. So 7 nodes away from the goal node. And the F cost is G plus H, so it's 11. And you can ignore these solid nodes for this calculation. So what we're gonna do next is calculate every node's G, H, and F cost and get them as data. So another method, private get cost, and we receive node. And first we calculate the G cost of this node. Okay, int x distance equal mass.abs, and we're gonna use this node's node size call subtract start node dot call. So this returns the x distance between the current node and the start node, and y distance equal mass.abs node.allow minus start node.allow. Then we're gonna, so this node's G cost is x distance plus y distance. Then H cost. Okay, I think we can just copy this and paste. So this time not start node but goal node, and this is H cost. Okay, and finally we get the F cost. So this node's F cost is node.g cost plus node.h cost. If node not equal start node and node not equal goal node, because we don't need to display these costs on start node and goal node. Node.set text, and since JButton doesn't really support line break function, so I use HTML tag just, you know, to handle line break. No. First F is node.f cost. Wait, something is strange. Yeah. Cost and plus, and here line break, and then G node dot G cost, HTML, and we don't really need to display H cost. H cost is only used for calculating this F cost. So you can display it if you want, but this time we only display F and G. Alright, then we use this get cost method and set these costs on all the nodes on the screen. So private void set cost on nodes. So we're gonna create another loop here. Then we're gonna call this get cost and pass node colon allow. Then call plus plus if call equal max call, then call is 0 and allow plus plus. And okay, then let's call this method from somewhere. Okay, yeah, let's check. Yeah, so we can see F and G cost on each node. Okay, now I'm gonna explain how A star algorithm evaluate these nodes. So right now we are here at the start node. Then the algorithm evaluates the costs of adjacent nodes. So this time I assume the player character or NPC or whoever can move 4 directions: up, down, left, and right. So that means we have 4 choices as our next step. So let's look at these F costs. So these two tiles are F11 and these two nodes are F13. So these two look more promising. So next we look at their G cost, and they are both 1. So the G cost is also equal. So the both nodes have exactly the same cost. So in this case, the algorithm selects both nodes and set them as checked. And now the program evaluates nodes that are adjacent of these checked nodes, F13, F15, and there are 3 F11 here, and all has 2 G cost. So we set them as checked. Now we have 4 F11 here and all has G3. So these look promising, so check these 4 nodes. And then F11 G4, so check. And F11 G5, check. And G6, G7, G8, and G9. But now these are solid nodes, so we cannot go any further. So this looked like a promising path, but now the program realized this is not the path to the goal. So it looks for the next promising node. Among these adjacent nodes, there is no F11, but we have some F13, and these two nodes have 1 G cost. So set them as checked. Then F13 and G2, 13.3 and 13 and 4, and this is F15, so F13 and 4 and F13 and 5, 13 and 6, and F15, so 13 and 7. And now the next node would be F15 and G2, so this one and this one, and 15 and this one first. This is also G2, so, and yeah, 15.3 and 15.3 and 15.4, 15.4, 15.5, 15.5, 15.5, and this is 6, so 15.5 and 15.6, 15.6 and 15.7 and 15.8, 15.9, 15.10. So this also looked like a promising path, but now the next node has F17. Because of this solid node, it's kind of moving away from the goal, and that's why the cost increased. So the algorithm abandons this path for now and evaluate other nodes. So the next one would be these F17 and G3, and also this one, and 17.4, 17.5, 76, 70, oh sorry, this one first, 76, 6, 6, and 17.7, and 17.8, 17.8, and 17.9, 17.9, 17.10, 17.10. And here the F cost decreases to 15 because there is no solid node, and it can kind of move in the direction of the goal. So this is the next one, and this is still F15, so choose this and this, and F15 to still F15, and next one is F13, so choose this, and so it has reached the goal. Yeah, so this is basically how A-star algorithm evaluates nodes and finds a path. So this time we did it manually, so it took a while, but if we let the program handle it, this can be done almost instantly. So what we're gonna do next is letting our program do what we just did, evaluating the costs and find the path. Okay, first let's complete this node class. So we add 3 more methods that we will use later. Public void set as open. When we call this method, we change this open boolean to true, and then public void set as checked. If start equal false and goal equal false, then we're gonna change this background color to orange. Set foreground black, and also checked equal true. One more method, public void set as path, set background color dot green, and set foreground color dot black. And this node class is done. So back to this demo panel class. Okay, we use this array list node, name this open list equal new array list. Another array list checked list, and also one more boolean, goal reached, goal false. Then we create a method, public void search, and we call this method every time we evaluate and check a new node. And first we check if we have reached the goal or not. Then we get our current nodes call and allow. Then current node dot set as checked, and checked list add. So we're gonna add this current node to this checked list, and also we're gonna remove this current node from open list. Yeah, I'm gonna explain a bit later, so let me type first. So every time we call this search method, we set the current node, so the node we are currently on, as checked, and add it to the checked list and remove it from the open list. So as I showed in this demonstration, this checked means we've already stepped on it as a best path candidate, and no need to evaluate it anymore. So we add all the checked nodes to this checked list, and I'll explain about this open list a bit later. Let's assume we just run this algorithm. We are at the start node at the beginning. Right now the current node is the start node. Then we evaluate these adjacent 4 nodes, and when we evaluate a node, first we change it to open state, which basically means this node is currently open for evaluation. And to do that, we create a method. So private void open node, and we get node if node dot open, so it's not opened yet, and also we check if node is already checked or not, and also we check if this is solid node or not. So node dot set as open, and node dot parent equal current node, and open list at node. Yeah, so we set it open and also set the current node as its parent, and we'll need this to track back the path when we reach the goal. And finally we add it to the open list. Then from here, so we pass a node to this open node. So open node call allow -1. So we set allow -1 because this node is one node above the current node. Then let's open the left side node. This time call -1 and allow. Allow +1. Call +1 and allow. Yeah, something like this. And we only do this when there is a node in these directions. For example, if the current node is on the top row, then there is no node above. And if the current node is on the far left column, then we cannot open a node on the left. And if we do, we get null pointer error, so we add some if statement to avoid that. Yeah, like this. So now we open these nodes and put them into this open list. And next we compare the nodes in this open list and find out which node has the best f or g cost. So first we create 2 integers. Then we create a for loop. Int I equal 0, size is open list dot size, and I++. So basically we scan the nodes that we put in the open list, then check if its fcost is lower than the current best node fcost. If open list dot get index I dot fcost is lower than best node fcost, best node index equal I, and the best node fcost equal open list dot get I dot fcost. So we put 999 to this best node fcost, so basically the first one automatically becomes a best node, but maybe the next one is even better, so we check that. And if its fcost is equal to the current best node fcost, we use gcost. So if open list dot get I dot fcost equal best node fcost, if open list dot get I dot gcost is lower than get dot gcost, then we're gonna update this best node index. And when this loop is done, we get the next best node. So we update this current node to open list dot get best node index. Yeah, so we do this because this is where we go next. And finally we check if this node is the goal node or not. Then goal reached equal true. Okay, let's check if this is working or not. And to do that, I'm gonna implement a enter key input. So we create a new class to handle key input. Key handler implements key listener, and we don't really use this and this, we only use this key pressed. Okay, so int code equal e dot get key code. Enter. Then, okay, before that, let's create a constructor. We get demo panel dp, and this dot dp equal dp demo panel dp. And so if you press enter, then we're gonna call p dot search. Alright. And back to the demo panel, and we're gonna add key listener to this panel. This dot add key listener key handler, this, and also set focusable true. Okay, let's check. So if you press enter, yeah, like this. Yep, So it worked just like we did before. Every time you press enter, the algorithm evaluates the adjacent nodes and find the best candidate until it reaches the goal. Okay, next let's automate this process. So we pressed enter key and called the search method by ourselves, but let's change it so the program repeats the process until it finds the goal. In case you want to keep this manual method, so I'm gonna copy and paste and name this auto search and change this if to while. Yeah, so this loop continues until this goal reached boolean becomes true. But also I think it's a good idea to set a limit of this loop, because in actual game there are situations that you can never find a path to the goal. For example, when the player character is totally surrounded by solid tiles or something like that. So if that happens, this loop never ends and it can freeze the game. So to avoid that, we create a variable and I will name step. So here at condition, so if goal reached first and also step is like less than 300. So in this case the algorithm stops the search after 300 steps. And so in every loop we add this, we increase this step. And in this key handler, so let's disable this and instead we're gonna call this auto search. Yeah, let's check. Okay, let's press enter. Yeah, like this. So the algorithm almost instantly reaches the goal. It's working great, but we are not done yet. Now the final touch. We're gonna backtrack these nodes and get the best path. So we create another and the final method. Private void track the path. Okay, first node current equal goal node. So we backtrack, so we start from the goal node and then while loop. So if current is not equal start node, then we're gonna update this current to this current node's parent. And if current is still not start node, then we're gonna call this set as path, which we created a while ago, set as path, and change its background color to green. And finally we call this method from here when we reached the goal, track the path. Okay, I think that's everything. So let's check. Alright, press enter. Yeah, like this. So this is the best path that this algorithm found out. And if you give these green nodes data to an NPC or a monster, they will know which direction they need to go. And I will make an implementation tutorial for my 2D game tutorial. So if you're following that series, please check the next video as well. Yeah, so even in a much more complicated situation like this, it can find out the path like this. Anyway, that's all for now. It's a little bit complicated, but pathfinding algorithm works really well in video game development. So hope this was useful for you. Thanks for watching and until next time.